to have any net requirement. What we receive can totally cover what we want. Then 0 for net requirement. And available inventory equals to the scheduled receipts minus the gross requirement. We use the 10 units. We have 5 units left as the inventory, so we put 5 over here. And then we move to the second column, week 2. We need 10 units again, and currently we have 5 units from week 1 as the inventory. We used all those inventory, and we still need 5 more. So that's why we have 5 in the net requirement. Okay, and according to the lot sizing rule, we have to place an order of 8 units. So we plan to receive 8 units for week 2 to cover the net requirement. And in order to receive the 8 units in week 2, we have to place the order in week 1. So that's why we have 8 over here under column 1. Okay. Now at this point, you have 5 as the net requirement. You have planned order receipts 8. 8 minus 5, that is 3, which is the available inventory for week 2. Then week 3, we have 0 requirement. That means we do not need to place the order, or we do not want to receive any order in week 3. And that's why we have 0 for the net requirement. But don't forget, we have 3 units as an inventory from week 2. So that's why we carry it over to week 3. So we have 3 as the available inventory in week 3. And finally, in week 4, we need 10 units, and we can use the 3 units from the end of week 3. That means we need 7 more. So 7 is the net requirement. And then we need to receive the order of 8 in week 4. In order to receive that order, we need to place the order in week 4. And finally, 8 minus 7, we have 1 as the available inventory at the end of week 4. So if you don't remember how to do this, you can go back to quiz 2, and also you can go back to Canvas. Which class is that? Let's see, probably is class 6, class 5 or class 6. I posted a video for doing this, so we can go back to Canvas class 6 to check the video. And here's the fixed ordering quantity 8. We probably see another question, the lot for lot. For that one, we will have different answers. Okay, so let's say we still have week 1, 2, 3, 4, and the gross requirement 10, 10, 0, 10, and schedule receipt 15 and 0, 0, 0. Then available inventory, net requirement, planned order, receipt, and planned order release. Okay. If we have lot for lot, that means no matter how many units we want, we can place the order of that same amount of units. Then again, starting from week 1, we want 10, and we expect to receive 15 in week 10. So we do not need anything over here. The net requirement is 0. And available inventory equals to 15 minus 10, that is 5. And then for week 2, we need 10, and we have 5 from the available inventory. So we need 5 over here for week 2. lot for lot, and FOQ. For FOQ, you have to place the order of a specific or fixed amount. But over here, unit 5, then we just place the order of 5. And in order to receive the 5 in week 2, we need to place our order of 5 in week 1 because of the 1 week lead time. Then 5 minus 5, that equals to 0. We have 0 available inventory left in week 2. Then for week 3, we don't need anything. We don't have anything, so all zeros. And in week 4, we need 10. So the net requirement is 10, and we want to receive 10. In order to receive this one, we need to place our order in week 3 and 0 inventory left. Okay, so that's the first question. Another question is from exam 2. Okay, so basically, please, it's about the reliability of the whole supply chain. And in exam, I will give you the formula as follows. I will show you how to calculate the reliability of the whole supply chain, how to calculate the reliability of the backup system. So for example, for this one, there are 3 suppliers with different reliability. Then what is the overall product reliability? You simply use the first formula and take all of them, multiply them with each other. Then you have the overall product reliability. The next question, based on the reliability, how many defective units are expected out of the 12,000 units? So based on question 1, we have the reliability. Then 1 minus reliability is the defect rate. So 1 minus 0.818, that is 0.182. You take the defect rate times the number of units to get the number of defective units. And let's say if the team is considering adding a backup supplier for one of this component, the backup has the same reliability, then what would be the new product reliability? The first step, you need to use the second formula over here to calculate the reliability of the component with multiple suppliers. So basically, you take 1 minus parenthesis, 1 minus the reliability of that component to the power of number of suppliers. So here, for the component C, the reliability is 0.899, right? So you take 1 minus parenthesis 1 minus 0.899, and we have 2 suppliers for this component. So to the power of 2 to get the reliability of that component. And the second step is we need to use, again, the first formula to calculate the overall reliability. We have the reliability for A, reliability for B, and this is the new reliability with C. And finally, how many defective units will now be expected? We just take the reliability 0.9, 1 minus 0.9, that is the defect rate, times the number of units. And then we move on to the content for exam 3. So you should pay more attention to quiz 5, 6, and 7. For quiz 5, it's about the optimization model. And see, here's different version of quiz 5. I changed a little bit the numbers for the questions, but basically you are doing the same thing. You need to define the decision variables, how many product or how many shipping boxes in this question to source from each supplier. So 4 decision variables. And then the objective function. So in this question, it says the unit cost for each supplier. So basically you want to minimize the total cost. But in the exam, I probably show you the unit profit you can generate from each supplier's product. Then you need to maximize the expected we have the carbon cap, the lead time. So let me explain the lead time. So in the question, it says the lead time risk control greater than greater than or equal to 50% of the total volume must come from supplier with lead time less than or equal to 13 days. All right. Then you go back to the table to see how many of the supplier have the lead time less than or equal to 30 days. There are two of them, C and D. So we need to make sure the number of boxes we source from C and D greater than or equal to 50% of the total volume, which is 4,000. So over here we have C plus D greater than or equal to 2,000. And we have single supplier limit. We need to make sure all of them are less than or equal to 40%. That is also the question's requirement. And the last one, don't forget about the non-activity constraint. I will not show you this constraint in the question description, but you should always remember to write down the non-activity constraint. And also, I will have some description about the integer constraint or binary constraint. And for example, probably I will say, if you source from supplier A, you cannot source from supplier B, or if you want to source from the suppliers, you will have to source at least two of them. So things like that, you need to use mathematical expression to show the constraint under the constraint section. And if you want to remind yourself how to do that, you can go back to class 18 to see how I did those constraints. Okay. And question 4. So it's again about the optimization model, but it's on the Excel side. How to interpret the result of the answer report and the sensitivity report. The first screenshot, objective cells, variable cells, constraints. These three tables are from the answer report. And the bottom, this one, the variable cells and constraint, this is from the sensitivity report. All right, and I will ask you questions like, can you tell which constraint is binding, which is not binding? Then you just focus on the answer report, the constraint table. And over here you can see I hide the status for the constraint. But I show you the slack value. And if the slack is 0, that means the constraint is binding. When it is not 0, then not binding. So that's the first question, which constraints are binding and why. Then, if the unit profit of supplier C increases to 2.95, will the optimal solution change? Of course, I will give you more context of the questions. But for answering this question, you can check the sensitivity report. Basically over here for the variable cells. It gives you the 3 decision variables. Okay? And the final value would be the optimal solution, the current optimal solution. And the objective coefficient shows the unit profit for each decision variable. So for example, 2.4 means the unit profit you can generate from supplier A's product. 1.39 is for supplier B. 2.87 is for supplier C. And the question says if we can increase it to 2.95, meaning we want to increase the 2.87 to 2.95, would that change our decision, the optimal solution? Then what you need to do is to see how much is the change. You take 2.95 minus the current unit profit 2.87. That is a 0.08 increase in the unit profit. And that increase is less than the allowable increase, which means you will not because we still source this much from B, and the unit profit increased from 1.39 to 1.89. So we would take the difference, 0.5, times the number of units we source from that supplier. That would be the increase in the total profit. So here I just show you some sample questions. You can see the whole set of questions in class 17. So I post the completed Excel file in class 17. I post all the answers. Go back to check the Excel file to see all the questions and see if you can answer them comfortably. Alright, so that's for optimization model, and then we have the AHB. So this one I think is the most complicated one, but I will guide you step by step. For this question, I say you have 3 suppliers, and you have 3 aspects of concerns or considerations: quality, delivery, and capacity. And you have different information about them. And based on the information about answer the following questions, you need to determine the weight of the criteria using the following pairwise preferences. I will tell you when you compare one criterion with the other, which one is more preferred and by how much preferred. For example, capacity is equally to moderately more important than quality. Then you go to the preference table to see equally to moderately preferred. That gives you a value of 2. So you can say the capacity compared to quality, the value equals to 2. Or in other words, capacity is 2 times more important than quality based on this pairwise comparison. And quality is moderately more important than delivery. Moderately preferred has a value of 3 according to the reference table. So Q divided by D, or Q versus D, equals to 3. Quality is 3 times more important than D, and so on and so forth. the formula, the best delivery time divided by the supplier's delivery time to get the raw score for each supplier, and then we need to normalize it. So the best delivery time for the three suppliers, we will go back to the problem description. We can tell for supply 1 it is 1.5 week, for supply 2 it is 1 week, supply 3 is 2 weeks. So the best delivery time is 1 week. We have 1. And then we use the formula to calculate the raw score for each supplier. We take 1 divided by 1.5 week, that's for supply 1, right? And the value is 0.667. And we do the same thing for supply 2 and 3. And at this point, you can easily tell that if you add them up, it doesn't equal to 1. So that means you need to normalize the result. And to normalize the result, similar to what we did over here, you just need to add them up to get the sum and take each value divided by the sum. So here we calculate the sum, 0.667 plus 1 plus 0.5. And then we take each value divided by the sum value. So 0.667 divided by 2.167, we have 0.308. That is the final score, or normalized score, for supplier 1. And similar for supplier 2 and 3. Okay. That's for HP. And then we have the ALN network diagram. Is for time management or schedule management for sourcing project. And I will show you the ALN diagram, and the first thing you need to do is to mark the earliest starting point, earliest finish point, latest starting point, the latest finish time for each activity, and calculate their slack. And you can just label them directly on the diagram. Okay. Then for the first question, how to mark those time. So we need to start with the very first node. So over here is node A. We can start right away in day 1 or week, day 0 or week 0. So 0 as the earliest starting point for A. And A takes 10 units back. Let's just say 10 days to finish. So 0 plus 10, we have 10 as the earliest finish date. And then we have B and C. And also D. They all depend on the completion of A. A can be completed in day 10. Then we can start B, D, and C on day 10. That's why we have 10 for the earliest starting point. And for B, the duration is 11. So 10 plus 11, that is 21. For C, 10 plus 8, that is 18. And for D, 10 plus 12, that is 22. And then we move forward to node E. Node E depends only on the completion of B, and that is 21. So we can start E on 21. 21 plus 10, that is 31. That is earliest finish point for node E. And similarly, we can have F. F depends on both C and D. C can be completed on day 18. D can be completed in day 22. And because F depends on both of them completed, then the earliest starting point is 22, the larger value between 18 and 22. And finally, we can calculate the time for G. And after you have the total forward pass, then you need to calculate the backward pass. Starting from the last node over here, we let the latest finish point equals to the earliest finish point. So we let this equals to 43 minus 9, that is 34. And we can go backward to E, D, and F. They are all the predecessor for node G. And we want to make sure we can start G as late as day 34. Then we need to make sure all of them need to be finished
Why would you crash D twice?
Because you see, D, the minimum is 4, right? You
Oh,
can do
okay.
this twice.
Yeah.
After you crash it to 5 weeks, and then you compare A, D, F, and G again and see, okay, D is still the cheapest one to do, so you crash it again.
Gotcha.
Alright, and we have the last type of question about spend analysis. So for spend analysis, you do not need to use Excel every time. I will show you the result of Excel. I give you the screenshot, and what you need to do is just to interpret the result. So for example, based on the following product category analysis, what managerial insights can you have? I have 8 different categories of products I want to source, and I have the category code, I have the actual spending for that year, relative spending, and number of unique suppliers for each category. And then you see, I already ranked them in the order in terms of the actual spending, right? So from the largest to smallest. Then from here we can see, for example, for the top 2, they are very important category. We spend a lot on them, almost 60% of the total spending. However, we only have 1 supplier or 2 suppliers for them. So probably that is a potential problem. We may rely too much on those suppliers. So to reduce the significant dependency on supplier and supply risk, we probably need to consider adding additional suppliers. And also for some product, for safety system, body and exterior components, and small parts and materials, they have too many suppliers. Then probably we can identify opportunities to reduce the number of suppliers. And then for the price analysis, PPV, that equals to the planned price minus the actual price. And we want to see what managerial insight we can make from this table. Here we have different suppliers. We have the average PPV of the supplier and the standard deviation of the PPV. Then we can tell from the average, the smallest one, or the most negative one, is the safeguard dynamic. The negative value shows we spent more than we thought. Right? The planned value is less than the actual payment. We overspending on those suppliers. And then we can investigate the underlying causes and review existing contracts and pricing agreement to see what happened with them. And for color code, power cord dynamic, and smart sync, they have relatively high value for the average, shown in green. So that means we underspent for those suppliers. We spend less than we thought, which sometimes is a good thing, but if you consistently underspend for those suppliers, and also they have very high price variability, then we also need to investigate what's going on